All right, everybody, welcome to Orgo 2 Lab CH4521. Here we are at Ear on Bossed Tanandum Catalysis. No, sorry, iron based tandem catalysis. I can speak the words. All right, here we see the TAs are setting up all of the appropriate glassware. We have a condenser being connected to our Clayson adapter that already had a thermometer adapter, and that condenser also had the drying tube, and so then they added the round bottom flask, and we have our thermometer being placed. Make sure you go low enough on the adapter. All right, see right there, you see right there in the neck of the round bottom. All right. Oh, and also do pay attention to the fact that it wasn't shown, but there is a magnetic stir bar in the bottom of that round bottom flask. All right. Here we go, adding water and in and an out hose to our condenser so we can reflux adequately. All right. Now they're going to go and weigh out all their stuff. So before they start doing that, they're making a paper funnel out of a piece of weigh paper. All right. And it's a little fuzzy, so you're going to have to take my word for that that we're weighing out the right stuff here. Okay. We know what we're doing. All right, so they're going to weigh out approximately 0.125 grams of BTM, which is a very short abbreviation for the TSNHCH2NHTS. A lot going on there. All right. All right, and then they're transferring it to the round bottom flask that's going to have our reaction going on in it. And then we have a blue topped bottle. What is it? Yeah, we can't see that. Oh, look, it's our iron triplet catalyst, which is moisture sensitive. So what that's telling me is, hurry up, weigh it, and put the cap back on ASAP. I mean, I feel like he's ASAPing it. Yeah. All right. So then he's adding the catalyst, and then wait for it. Wait for it. There we go. Our mass was 0.0108 grams of catalyst. All right, now you can see that they're adding the DCE, which is short for dichloroethane. They're adding 2 milliliters to the round bottom flask. It's going to be our reaction round bottom flask. All right, add away, add it, get it done. All right. All right, next we have a micropipettor, and we're going to get a tip. I don't know why we had well, whatever. Oh, we can see that alpha methylstyrene. Sweet, that was in focus. All right, so now they're going to take approximately, well, it needs to be 13 microliters of alpha methylstyrene. And as you can see, they added it to the reaction round bottom flask. All right, get it done. Good job, man. Good job. All right, now they're going to connect the round bottom flask to the bottom of the Clayson adapter. Then they're going to lower it so that we can see it spinny spin and heaty heat. I feel like it's getting hot in here. If it does, you need to go turn your thermostat down. All right, and here we're doing hand gestures. We're we're zooming in, we're zooming out, we're pointing. Okay. All right, here we go. Refluxing, refluxing, refluxing. All right, notice this yellowish, light yellow, and look, it's starting to get a little darker, and then it's going to almost look brown, which means it's like a super concentrated orange color. Yeah, yeah. And everything's going to move really quickly once they actually take this off, but they're going to take it off of heat so it can cool to room temperature. We're not going to actually stare at it via video form for 45 minutes to an hour to wait for that to occur. But we will cut to preparing the TLC plate and the TLC jar. All right. As I said, removing from heat to allow to cool. All right, they're going to put a line approximately 1 centimeter from the bottom of the plate. And then we're going to have two tick marks, an SP mark and a P mark. So standard product for SP, and your experimental product will be just P. All right, and so here we see them preparing our mobile phase for our TLC plate. They're going to have 4 milliliters of hexane and 2 milliliters of ethyl acetate involved in this. Here we go. All right, almost done. Let's get that ethyl acetate. We can do this. All right, there we go. Okay, once they pour that in, we'll be good to go with our mobile phase, so they can put the cap on. Now we'll swap over to making our column. So we're going to get a pasture pipette. There it is, a stick and a piece of cotton, not the whole thing. We're going to poke that cotton down at the bottom of the pasture pipette, so once we have the silica, it won't go anywhere. All right, there we go. All right, now we're going to add silica to it. All right, how we going to do this, y'all? We just going to stick it in the container that contains it. Okay, that's one way. All right. I mean, that's a quick way. All right. Now removing our reaction flask. All right. Now they're going to transfer this reaction mixture to a rotovap brown bottom flask, the bigger one. Okay. And then they're going to use DCM to try and grab any leftover reaction mixture. There we go. All right, and they're not just pouring it in there because, well, they don't want to put the magnetic stir bar in the rotovap flask. All right, here we go. All right, rotovapping. You're gonna want to watch this fairly closely. It happens pretty quick. All right, so if you look at the bottom, we're gonna see less liquid, a lot less, a bubble, liquid, 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 liquid. Ooh, it gone. It's big old gone. All right, so at this point we take it off the rotovap. All right, this is our empty rotovap. Okay, so this is actually before we ever put it on the rotovap, but that was our empty rotovap flask. So now they're going to add some DCM to dissolve any of that solid. One of the main reasons they did this step was so that they could get rid of the DCE. Okay, that's what's kind of vital here. One, because it's expensive, but um, anyway, so they're redissolving their solid now using just DCM. All right. All right, now they're taking that redissolved solid and they're putting it in on top of their column. All right, they're going to use this hand pump in order to push it through the column, maybe speed up the process a little bit. Okay, you do want to make sure that when you're putting your solution into that pasture pipette column, that little divot right there above the TA's gloves, you want to make sure you don't overfill it. And he did. So now what are you going to have to do? You're going to have to wait. Sit there and wait. All right. Anyway, so at this point he can pump it through. Now, one of the reasons you don't want to fill it above that divot is because if you have some kind of problem with the hand pump and you accidentally suck solution into it, every time you use that hand pump thereafter, you could contaminate your next sample or the sample after that or the sample after that. So it's that's why I say just wait. If you go above the divot, just wait. It shouldn't take too long. Anyway, so they're doing the same thing they did earlier, where they're adding a little bit more DCM to the rotovap flask to try and catch any of the undissolved product. All right, and they're pushing it through. They're going to break on through to the other side. All right, and you'll notice that all that brown stuff being trapped at the top. Okay, that would hopefully, once you do this, it'll make sense to you, but hopefully, that should be your iron catalyst remnants that's getting trapped. Okay. All right. So shaky. They keep zooming in and out. Oh, there it goes again. Here it goes. Here it goes. Wait, why did you put that little bit? No, sir. No, sir. He broke the rules. It's okay. Just breathe. But no, it'll be okay. He knows what he's doing, so he's not going to accidentally suck it up into the air pump. So, all right. But you don't. You don't know what you're doing yet. Okay? Okay? All right. I think it's through. Let's put the next stuff in there. Oh, we're done. Okay, so there's the column after it's all done. Now, what you see in that glass vial there, that is your standard product, your SP. Um, yours, and that's something you're going to get from the TA. Okay, we know that is the product of choice. That's the product we want to make here. And then here's our reaction mixture that's gone through the column. Okay, and this will be represented by your P, right? Not urine, but the letter P. Okay, on the TLC plate. There we go. All right, put in the plate in the TLC chamber. Putting the lid back on. All right. Okay, and then due to the magic of television, you are done. So let's take it out. All right. It was maybe a centimeter or two before the top of the plate. So they put the line there so that you can have the solvent front. Under UV, you can see for P and SP, that big dot, that big blank spot right there, we did make our product. But we also have that little dot below in the P column. We have that little dot. So that could be unused reactant. All right, and we're back to evaporating it because you're going to see an image of a mass. Record that, pause it and record. That will be the mass. You'll use that and the previous picture with an empty round bottom flask and subtract those two numbers. That'll give you the mass of your product. All right, go live La Vida Loca. Adios.